We are going to start now the next lecture, lecture 2 of chapter 14, class 10th mathematics statistics. In this lecture, we will talk about the methods of calculating the median and mode of the grouped data. So first we are calculating the median. So median is the measure of central tendency which gives the value of the middlemost value of the observation. This is the definition we are saying, that when we are talking about median, so it is a measure of central tendency and it gives us the value of the middlemost observation of the data. So in our previous lectures of class 9th, we have already studied that if an ungrouped data is given to us and there are n observations, then the formula for the median it is, so there are total n observations. If this n is odd, then it is n plus 1 by 2th observation, and if n is even, this number of observations it is even, then the formula is n by 2th observation plus n by 2 plus 1th observation divided by 2. For problems based upon this formula, you can refer to the videos related to class 9th. Now in this class, we are going to calculate the median for grouped data. So suppose the values that are given to us, that class interval is given, say it is 0 to 10, 10 to 20, 20 to 30, these are the class intervals given to us, and then corresponding frequencies f1, f2, f3, these frequencies, these are given to us. So the first step we have to do is we have to find the sum of all these frequencies. We are saying it is sigma fi, this is equal to the total number of observations that we have. The next step we have is we have to find the value of n by 2 and look at the cumulative frequency just greater than n by 2. It means we have to calculate the value of CF, cumulative frequency. Cumulative frequency means f1, then f1 plus f2, then f1 plus f2 plus f3. We are saying this is the total value n. We have calculated n by 2. We have to find that class, we are talking about that class for which this cumulative frequency is just greater than the value n by 2. Suppose it is this class, then this class is called the median class. This class is called the median class, and we are saying that the middlemost value will lie in this class. Now to compute the median, we will use the formula. This formula is given over here, that median is equal to L plus H into n by 2 into CF over F. Now what these terms are, L is the lower limit of this median class. If I am talking about this is the median class. How we have calculated median class? We have calculated n by 2. These will be some numbers, f1, f1 plus f2, f1 plus f2 plus f3. We are saying the number which is just greater than this n by 2, corresponding to that number, the class that we will have, that is called the median class. L is the lower limit of this median class. It means this value 10, this is L, and H is the width of the median class. Width means this, we are saying the value it is 10. It is 20 minus 10 is equal to this. This is the width of the median class. Then multiplied by n by 2, we have already calculated. CF means cumulative frequency of the class preceding the median class. We are saying CF means the cumulative frequency of the class preceding the median class. It is before that, the cumulative frequency before that class, and this value F, it is the frequency of the median class. So on our next slide, we solve a problem, and how we apply this formula, it will be more clear to you with this example. So this data is given to us. These are the marks and these are the number of students, frequency we are saying. These are the frequencies given to us corresponding to these marks. So to compute, we have to find the median for this data. So we are saying we have written the classes over here. It is 20 to 30, 30 to 40, 40 to 50, 50 to 60. These are the classes. Then the frequencies are given to us, it is 5, 15, these are corresponding to these classes. These frequencies are corresponding to these classes. Now next we are calculating the cumulative frequency. Cumulative frequency means this is the frequency corresponding to all the values less than 30. This is the value corresponding to less than 40, less than 50. So this is the cumulative frequency. How we have calculated this value? It is 5. Then 5 plus 15, it is 20. 20 plus 25, it is 45. 45 plus 20 is 65. Then 65 plus 7 is 72. So these are the values of the cumulative frequency. This sum over here and this value over here, these should be equal. This is the method to check whether your calculations are correct or not. So we are saying the value of n, now we have it is equal to 90. So now the next step we have is we have to calculate the value of n by 2. So the value of n by 2 we have it is 45. Now look at the value over here, the cumulative frequency. This is the value 45 that we have. So we are saying the cumulative frequency just greater than 45. We are saying this value over here, this is the value 45 that we have. But what was our formula saying? That we want the cumulative frequency just greater than 45. So that value is 65. It means this class we are talking about, 50 to 60, this class we are saying, this is the corresponding median class. This class we are talking about, this is the median class. Suppose the value, if suppose in place of 45 we obtain it is 44, then the median class would be 40 to 50. But over here we are obtaining this value is 45. We are talking about the cumulative frequency just greater than 45. So it is 65. So the median class it is 50 to 60. Now corresponding to this median class, this is the value of L. L is equal to 50. The value of H is width of this class, that is equal to 10. Now the formula we have, it is L. L is the, this value 50 we are saying, this is the value of L. Then it is into H. H is the width of the median class. Next is n by 2. N by 2 we have already calculated, it is 45. CF means the cumulative frequency of the class preceding the median class. So we are saying the value of CF that we have, it is 45 and divided by the frequency of the median class. This is important to note over here that CF is for the preceding class of the median class and F is the frequency of the median class. So when we substitute all these values in this formula, we will get the answer in the form, it is 50 plus 10, 45 minus 45 over 20. So the answer we obtain, that is equal to 50. So we are saying the median for this data, it is 50. Now in this next question, we are given the wages in rupees. These are the classes given to us. It is 800 to 820, 820 to 840, 840 to 860. And these are the corresponding frequencies, number of workers having these wages in these range. These are given to us. So we have to calculate the median wage. So to calculate the median wage, we are saying we have written this complete information in this tabular form. We are saying these are the classes we have. These are the corresponding frequencies. From these frequencies, we have written the cumulative frequency. This value is 7. Next value we have it is 7 plus 14 is equal to 21. Next value we have it is 21 plus 19 is equal to 40. Next value we have it is 40 plus 25 is equal to 65. So we are saying we have calculated this value is 7 plus 14. This value is 19 plus 21. These values we are talking about. So we get the cumulative frequency and the value of n that we have, it is equal to 100. So n by 2 we calculate, that is equal to 50. Now 50 is somewhere over here. We are talking about this number 50. It lies somewhere over here. So the cumulative frequency greater than 50. that is just next to 50, it is 65. It means the median class that we have. We are saying it is the median class that we have. It is 860 to 880. From this median class we obtain, this is the value of L, that is 860. The value of H that we have, it is equal to 20. It is difference of these two values. It is 880 minus 860, that is equal to 20. This is the value of H. Now the formula we have, it is L plus H into N by 2. N by 2 we already have, minus CF over F. CF is cumulative frequency of the preceding class. Cumulative frequency of the preceding class means it is 40, and the frequency of this median class, it is 25. So when we substitute these values in this formula, the calculations are shown in our next slide. The answer we will obtain, that is 860. This is the value of L. Then H is 20. Then it is 50 minus 40 over 25. Now how we are going to solve this is, first of all we are going to solve this bracket. The answer we obtain, it is 10. So it is 860 plus 20 into 10 by 25. This is bracket over here. It is important to note that first of all you have to solve this term. Generally what students commit the mistake, it is 860 plus 20 into 10 by 25. What they do is they add these two terms. The answer they write from this, it is 880 into 10 by 25. But this thing is wrong, because first of all we have to multiply these two terms. You are saying we have to multiply these two terms, and on multiplying these two terms the answer you will get, it is 8, and the final answer, the value of the median we will get, it is rupees 868. So you must check that the answer you are obtaining, this 868, this must lie in the median class. We are saying the median class that we have, it is 860 to 880, and this value of median, it lies in this class. So we can check from this. If suppose the answer you are getting, it is outside this class, it means you have committed some mistake in calculating the answer. Now the next question we have is to calculate the median for inclusive series. Now the data that is given to us, it is the height in centimeter and the frequency. So the value of height that are given to us, the range that is given to us, it is 160 to 162. The next value we have, it is 163 to 165. So look at these two values over here. So we are saying the data that is given to us, it is in the inclusive form. So first of all we have to convert these values to the exclusive form. So we know what is the procedure. It is 160 to 162. Next it is 163 to 165. If we look at these values over here, so difference between these two values, it is 163. We are talking about these two values. It is 163 minus 162, that is equal to 1. Half of this value, it is 1 by 2, that is equal to 0.5. So what we have to do, we have to subtract 0.5 from this value and add 0.5 to this value. The answer we will obtain, it is 159.5 to 162.5. This is our first interval. This value we are saying, this is our first interval. Next, for the second, we are subtracting 0.5 from this, we are adding 0.5 to it. The intervals that we will obtain, it is 162.5 to 165.5. These are the intervals we are talking about. So this is our second interval that now we have. So what we have done, we have converted this data given in inclusive form to the exclusive form. Next thing we have to do is, we have to write, these are the frequencies that are given to us. These frequencies, these are already given to us. We have to write the cumulative frequency, it is 15. Next value, it is 15 plus 117. Next value, it is 132 plus 117. We are saying it is 15 plus 117. And then next value we have, it is 132 plus 136. It is not 132 plus 117, it is 132 plus 136. The answer we get it is 268. Likewise, we obtain these values as the cumulative frequencies. Now the value of n that we have it is 400, n by 2 we have it is 200. So the cumulative frequency is just greater than 200. It is 268. It means this class. We are saying this 165.5 to 168.5. This class we are saying this is the median class. If this is the median class, then the value of L that we have, it is 165.5. The value of H that we have, it is 168.5 minus 165.5, and the answer we obtain for this, it is equal to 3. This is the value of H. This is the value of L. Next value we require n by 2. N by 2 we already have it is 200. The next value we require it is CF. It is cumulative frequency of the preceding class, and it is 132. And the frequency of this class, it is 136. We are saying it is the frequency of this class, it is 136. So if we substitute all these values in the formula we have, we are showing these calculations on the next slide. It is L, the value of L is 165.5. Then it is H, the value of H we have it is 3. Then it is n by 2 minus CF, so it is 200 minus 132. And in the denominator we have it is F, so it is 136. Again, we have first to solve this value. On solving this value, the answer we are getting it is 68. Now next we have to calculate this value. On solving this value, we are getting it is 1.5, and the final answer, the median in this case we obtain it is 167. So median height we are saying it is 167 centimeters. I am again repeating over here that you must keep in mind that how these brackets are to be solved. These brackets I am talking about. First of all, you have to multiply the terms, then you will add the terms. This is very common mistakes that students commit. What they do is 165.3 plus 3 into 200 minus 132 by 136. How they start calculating it? They add these two terms. They write it is 168.3. They solve this. It is multiplied by this value. It comes out to be 68 by 136. They solve this value and whole answer becomes incorrect. Because what you have to do, you have first to solve these bracket and then add the answer to this value. Now next is given below is the distribution of IQ of 100 students. Find the mean IQ. So these are the values given to us. This range is given 75 to 84, then 85 to 94, 95 to 104, and these are the corresponding frequencies that are given to us. Now again this data, it is given in the inclusive form. So we are converting it to exclusive form. Again, the difference between these two values, it is 85 minus 84, that is equal to 1. Half of this value, it is 0. If we divide it with 2, the value we have 0.5. It means how the median class is going to change. We have to subtract 0.5 from this value, add 0.5 to this. Subtract 0.5, add 0.5. Subtract 0.5, add 0.5. Subtract 0.5, add 0.5. Subtract 0.5, add 0.5. We have to perform this on all these values, all these classes, and the answer we are obtaining over here, it is 74.5 to 84.5. Next class will be 84.5 to 94.5. Next class will be 84.5 to 104.5, and these are the corresponding frequencies. Now from these values, we have next step we have to do is we have to write the cumulative frequency. So this is 8. The next value we have it is 8 plus 11, that is equal to 19. The next value we have is 19 plus 26, that is equal to 45. Now continuing in this way, we obtain these cumulative frequency corresponding to these classes. Now the value of n that we have, that is equal to 100. The value of n by 2 we have, it is equal to 50. Now the cumulative frequency just greater than 50, it is 76. So we are saying this is the median class. This class we are saying this is the median class. Corresponding to this median class, we obtain the value of L, it is 104.5. Value of H, it is 114.5 minus 104.5, and the answer we have, it is equal to 10. This is the value of H that we have. Next we require is the value of N by 2 we already have. Next we require is the value of CF. This is the cumulative frequency of the class preceding the median class. So this value, it is 45, and the value of frequency of the median class we have, it is 31. So these are the values that are to be used in the formula. So the answer we will obtain, it is 104.5 plus this bracket over here, then it is H10 into, again the bracket is over there. The next value we have, it is n by 2, that is 50 minus 45 over 31. Now what we have to do, first of all we are solving this bracket. So on solving this bracket, the answer we will obtain, it is 5 by 31. Then we multiply these two terms, the answer we will obtain, it is 50 by 31. So 50 by 31, that will be equal to 1.6. So answer we are writing, it is 104.5 plus 1.6, and that is equal to 106.1. So we are saying the median we obtain, it is 106.1. Now the next question we have is calculate the median for the following data. The data is given in this form, that marks below 10, then marks below 20. So these are basically the cumulative frequencies that are given to us. So when we are talking about marks below 10, it means we are talking about these are the marks from 0 to 10. Marks below 20 means 0 to 20. Then it is 0 to 30. So first of all, we are writing these in the, we are in place of this below 10, below 20, below 30. We are writing the class intervals in the form 0 to 10, 10 to 20, 20 to 30. So 0 to 10, how many marks we have? It is 6. The frequency we have, it is 6. Next we are talking about below 20, it is 0 to 20. So we are saying from 0 to 20 there are 15 students. From 0 to 10 there are 6 students. So from 10 to 20 we will have 15 minus 6, that is equal to 9 students. So we are writing it is 15 minus 6, that is equal to 9. Next value we have, it is 29 minus 15. The answer we will obtain, it is 14 students, those who have marks between 20 to 30. So in this way, by subtracting these values over here, we obtain the frequencies corresponding to these class intervals. We are saying these are the class intervals and these are the frequencies. Now the cumulative frequency, it is already given to us. We are saying the cumulative frequency means, we are saying the students having marks 0 to 10, it is 6. Student having marks 0 to 20, that will be 15. This is the meaning of cumulative frequency. Then 29 is representing the students, those who have marks less than 30. So it is already given to be 29. Now the value of n that we obtain over here, it is 70. This is the value of n that we have. Next step we have is, we have to calculate the value of n by 2, that is equal to 35. Now the cumulative frequency just greater than 35, it is 41. It means the median class we have, it is this. This is the median class. If this is the median class, then what we get is the value of L we have, it is 30. The value of H we have, it is 40 minus 30 is equal to 10. The value of CF we have, CF is the cumulative frequency of the class preceding the median class, it is 29, and the frequency f we have for the median class, it is 12. Now if we substitute these values in the formula, we will have it is 30 plus, it is bracket over here, then it is 10 into the next values we have, it is n by 2, that is 35 minus a CF over F. Now on solving these values, the final answer that we will obtain, we are saying we are going to solve this part of the bracket first. So it is 35 minus 29 by 12. You will solve this value first. Then you will multiply this value with 10, and then you will add this answer to 30, and the final answer you are obtaining over here on solving this, that will be 35. So we are saying that the median of this data, it is 35. Now the next question we have is find the missing frequencies in the following frequency distribution table if the value of n, the total values we have, it is 100, that is total frequency, it is 100, and the median we have, it is 32. So if median is 32 and we know that the median will lie in the median class, it means the median class for this data, it is 30 to 40. From this 32, we are saying the median class will be 30 to 40. Suppose the missing frequencies, we are saying these are F1 and F2. If we add all these frequencies, it is 10 plus F1 plus 25 plus 30 plus F2 plus 10. We are talking about this value. This should be equal to 100. The sum is 100. On adding these values, we will get the answer as, it is F1 plus F2 is equal to 25. Now the median class we have, it is 30 to 40. Now we are saying the median class we have, it is 30 to 40. I am again explaining because this value is 32. So that is why we are saying the median class is 30 to 40. So the value of L that we have, that is equal to 30. The value of H that we will have, that is equal to 10. Next thing we require is the value of N by 2, that will be equal to 50. Next we require the value of CF, that is the cumulative frequency of the class preceding the median class. We want the cumulative frequency up to this. So if we write the value of CF, this is 10, then it is 10 plus F1, and this is 35 plus F1. So we are saying the value of CF we have, it is 35 plus F1. The next value we are saying, it is F, that is frequency of the median class, and the frequency of the median class, it is 30. Now if we substitute these values in the formula for the median, the answer we will obtain, it is 30, that is the value of L, into H is 10, into N by 2 is 50, minus CF is 35 minus plus F1 divided by 30, and this answer, this is given to be equal to 32. That is the median that we have. So if we shift this 30 on this side, or we are saying we are subtracting 30 from both sides, and this 3 and 10 gets cancelled, so we are left with this 50 minus 35 plus F1 over 3, that is equal to 2. We multiply both sides with 3. The answer we are writing, it is equal to 6. So we are writing it is 50 minus 6, and that is equal to 35 plus F1. So this gives us the value of F1 we have, it is 44 minus 35, and this is equal to 9. Now substituting this value of F1 in our equation that we have already formed over here, that F1 plus F2 is equal to 25, we substitute this value of F1 in this equation to obtain F2 is equal to 25 minus 9 is equal to 16. So the value of F1 and F2 that we will have, it is F1 is equal to 9 and F2 is equal to 60. Now the next we have is mode of the grouped data. Mode we already know is the most frequently occurring value. So if the data is given in ungrouped form, then the value which is having the maximum frequency, that is called the mode of that data. Now if the data is given in the grouped form, so first of all we have to find the modal class, and modal class is the, in the frequency distribution, it is the class having the maximum frequency. It is called the modal class. Suppose we are saying the values that are given to us in this form, it is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and the corresponding frequencies are given to us. It is 3, 7, 5, 8, 2. So modal class means we are saying the maximum frequency, it is 8 over here, it is corresponding to this class. So this class we have over here 30 to 40, we are saying this is the modal class. We have just to look this frequency over here, these are the Fi. So the maximum value of frequency we have to find, and corresponding to that it will have the modal class. Now the formula to calculate the mode, it is xk plus h into fk minus fk minus 1 divided by 2 times fk minus fk minus 1 minus fk plus 1. Now what these values are? If this is the modal class, this value 30 we are saying, this is the value of xk. The lower limit of the modal class, it is the value xk. Now the frequency corresponding to this modal class, that is the value fk. Fk minus 1 is the value of the frequency preceding that modal class, and fk plus 1, this is the frequency of the class succeeding the modal class. And this h we are saying, this is the width of this modal class, that is 40 minus 30, that is equal to 10. So we substitute all these values in this formula to find the mode of the given grouped data. So we explain this formula with our next example. So this data is given to us, it is the class and the frequencies, these are given to us, these are the class, these are the frequencies. We have to find the mode. So first step we have to do is we have to look at this data, look at this frequency, and we can see that the maximum frequency is for this class. It means this class over here 60 to 80, this is the modal class. If this is the modal class, it means the value of xk that we have is equal to 60, and the value of h that we have, it is 80 minus 60 is equal to 20. The frequency corresponding to this class, we are writing it is f of k. The frequency corresponding to the preceding class, it is fk minus 1. The frequency corresponding to the succeeding class, it is fk plus 1. Now the formula for the mode we have, this is the formula to calculate the mode of this data. So we are saying the value of xk we have, it is 60 plus, it is bracket over here. Next we are saying it is h is 20, and the next terms are again in multiplication. So it is fk is the frequency of this class, it is 12. Frequency of the preceding class fk minus 1, that is equal to 10, divided by 2 times fk. The value of fk we have, it is 12, minus fk minus 1 means it is 10, and fk plus 1 it is 6. We have to subtract these values. Now again, first of all we are solving this bracket. The numerator part, it is 2 over here, and on solving this, the denominator we will get, it is 24 minus 16, that is equal to 8. So on solving this, we will get it is 60 plus 20 into 2 by 8. On solving these values, now next thing we have to do, we have to solve this bracket. So it is 60 plus 5, and the answer we obtain, it is 65. So we are saying the mode we have, that is equal to 65. Next is the distribution of sales of shirts sold in a month in a departmental store is as under. So these are the size in centimeter that are given to us, and these are the corresponding frequencies. Now we have to find the modal size of shirts sold, that is we have to calculate the mode. So to calculate the mode, the first step we have to look at these frequencies. These are the number of shirts, it means these are the values of frequencies. So we are saying the value having the maximum frequency, it is 155. It means this is the modal class we have. This is the modal class. So the value of xk that we have, it is 95. The value of h that we have, it is 100 minus 95 is equal to 5. Now the frequency corresponding to this modal class, it is fi. Frequency corresponding to the preceding class, it is fi minus 1, and frequency corresponding to the succeeding class, it is fi plus 1. Now substituting these values in the formula, we get that the mode is equal to xk, it is 95, plus the value of h we have, it is 5, then it is multiplied by 155 minus 85 divided by 2 times 155 minus 85 minus 110. Now on solving this, we will get this value. When we will subtract, this is 70, and the denominator part, when we will solve, this will become 310 minus 195, and this value comes out to be 115. So our answer becomes 95 plus 5 into 70 by 115. On solving this, we will get it is 95 plus 70 by 23, that is equal to 95 plus 3.04, and that is equal to 98.04, and this is the mode of this data. Now next is given below is the frequency distribution of heights of player in a school. So these are the heights given to us, and it is important to note over here that this value is 162, this value is 163. It means the data that is given to us, that is in the inclusive form. So to solve this, we have to convert this data into the exclusive form. So how we are going to convert it is 162 minus 163 minus 162. The value we have, that is equal to 1. Half of this value, it is equal to 0.5. So we are saying when the interval we have, it is 162. So what we have to do, we have to subtract 0.5 from this, we have to add 0.5 to this. So the interval we get, it is 159.5 to 162.5. So our this data, this will be converted to this form. Now the class intervals that we will have, it is 159.5 to 162.5, 162.5 to 165.5. Next it is 165.5 to 168.5, and these are the corresponding frequencies that we will have. The maximum frequency we have, it is 142, and it is corresponding to this class. So the value, this is the modal class. Now if this is the modal class, so value of xk we have, it is 165.5. The value of h we have, it is 168.5 minus 165.5, and the answer comes out to be 3. Now this is the value fk, this is the value fk minus 1, this is the value fk plus 1. So by substituting these values in the formula, we will get it is 165.5 plus h is 3, then into 142 minus 118 divided by 2 times 142 minus 118 minus 127. So on solving these values, the answer we will obtain, on solving this value, it is 24. On solving this, the answer we will obtain, it is 39. On solving this complete term, the answer we will obtain, it is 165.5 plus 1.85, and the answer comes out to be 167.35. So we are saying the modal height we have, it is 167.35. Now the next we have the following table shows the ages of the patients admitted in a hospital during a month. Again, if we look at these values, the data given to us, it is in the inclusive form. So to convert it to the exclusive form, we are subtracting 0.5 and adding 0.5 to the lower and upper limits of these classes, and this data will convert to the form. These classes we will obtain, it is 5.5 to 15.5, then 15.5 to 25.5, then 25.5 to 35.5, and like so on. Now we have to find the mode and mean of the data given above, compare and interpret the two measures of central tendency. So we have to calculate the mean as well as the mode. So we are writing this data in the form, it is 5.5 to 15.5, then 15.5 to 25.5, then 25.5 to 35.5. Next we are writing, it is 35.5 to 45.5, then 45.5 to 55.5, and then 55.5 to 65.5. These are the classes we have. Now the frequencies we have Fi, they are 6, 11, 21, 23, 14 and 5. Next thing we have to calculate, it is Xi. So that will be the sum of these two values divided by 2. The answer we will obtain, that is equal to 10.5, 20.5, 30.5, 40.5, 50.5 and 60.5. Now we are assuming the mean to be 40.5. We are using the assumed mean method. We assume that the mean is 40.5. So the value of A that we are assuming over here, that is 40.5. So the value of Di we will obtain, that will be 0, minus 10, minus 20, minus 30, 10 and 20. Now the common value over here, it is 10. So we assume H is equal to 10. We are using step division method, and we get Ui is equal to minus 3, minus 2, minus 1, 0, 1, 2. Next step we have to calculate Fi into Ui. So it is minus 18, then minus 22, then minus 21, then 0, then 14 and then 10. When we sum all these values, we will get the value of sigma Fi Ui, that is equal to minus 37. So the mean that we will obtain from this, that will be equal to the mean. Formula for the mean we have, it is A. Value of A, it is 40.5 plus the value of H we have taken, it is 10, into sigma Fi Ui is minus 37 over sigma Fi. When we calculate sigma Fi, the answer we will obtain, it is 80. On solving these values, the answer we will get, it is 40.5 minus 4.63, and that is equal to 35.87. So we are saying the mean that we will obtain, that is 35.87. Now next we have to calculate the mode for this data. So for mode, we are saying the maximum frequency we have 23. So this is the modal class. So the value of xk we have, it is 36, 35.5. This is the value of xk we have. The value of h that we will have, that is equal to 10. These values, these are mentioned over here. The value of xk we have, it is 35.5. The value of h we have, it is 10. Now this is the value of Fi. This is Fi minus 1. This is Fi plus 1. These values, these are also mentioned over here. Now when we substitute these values in this formula, the answer we will get, it is 35.5 plus 10 into 23 minus 21 over 2 times 23 minus 21 minus 14. On solving this, the final answer we will obtain, it is 37.32. On solving this, we will obtain this answer. So we are saying the mean we have, it is 35.87, and the mode for this data it is 37.32. Now next thing we have to do is we have to interpret the two measures of central tendency. So this interpretation is given on our next slide. So it is the modal age is 37.32. This thing we are talking about. So this thing means that the maximum number of patients admitted in the hospital during the given month, it is the maximum number of patients admitted in the hospital during the given month are of the age approximately 37.32 years. While when we are talking about the mean age is 35.87 years, this means that on an average the age of patient admitted to the hospital it is 35.87. So the mode it gives us the maximum number of patients were having the age nearly 37.32 years, but the average age of patients it is 35.87 years. Now the next is the mode of the following series is 36. We have to find the missing frequency. So suppose this missing frequency we are saying it is x. Now if the mode is 36, it means this value of mode it should lie in the modal class. So the modal class we will have it is 30 to 40. This is the modal class. So if this is the modal class, it means the value of xk we will have it is 30. This 16, this is the value of fi. This 12, this is value of fi plus 1, and this x it is the value of fi minus 1. So we are saying the mode we have it is 36, and the formula for mode it is 30 plus h. The value of h we will have it is 40 minus 30 is equal to 10. So it is 10 into the value of fi it is 16, fi minus 1 it is x over 2 into 16 minus x minus 12. So if we subtract 30 from both sides, we will get 6 is equal to 10 into 16 minus x over 20 minus x. So on solving this, we cross multiply these terms, we will get it is 120 minus 6x is equal to 160 minus 10x. So this gives us 4x is equal to 40 or x is equal to 10. So we are saying the missing frequency we have it is equal to 10. The next question we have is compare the modal ages of the two groups of students appearing in an entrance exam. So there are two groups of students, group A and group B. These are the class intervals given to us. These values, these are the class intervals. It is 16 to 18, 18 to 20, 20 to 22, 22 to 24, and these are the corresponding frequencies. We have to find the mode for both these groups. So when we are calculating the mode for the group A, the maximum frequency we have it is 78. So the modal class we have it is 18 to 20. So the value of xk we have it is 18. The value of h we have it is 2. The value of fi we have it is 78. The value of fi minus 1 we have it is 50. The value of fi plus 1 we have it is 46. So corresponding to the group A, the value of mode we have that is equal to 18 plus 2 into 78 minus 50 over 2 times 78 minus 50 minus 46. So that is equal to 18 plus 14 by 15, that is 18 plus 0.93, that is equal to 18.93. Now when we are talking about the group B, we are saying the modal, the maximum frequency we have it is 89 over here. So the value of xk, again this is the modal class, it is 18. The value of h we have it is 2. Now the value of fi we have that is 89. The value of fi minus 1 is 54. The value of fi plus 1 is 40. So the mode corresponding to this group B, it is 18 plus 2 into 89 minus 54 over 2 times 89 minus 54 minus 40. So answer comes out to be 18 plus 70 by 84. When you solve this value, you will get it is 70 by 84, and this comes out to be 18 plus 5 by 6, and the answer we obtain it is 18.83. So we are saying the mode corresponding to this first value, it is 18.93 for the group A. This is MA, and this is the value of MB. This is mode corresponding to the second group. So what we obtain is that the modal age is from group A, it is greater than the modal age for the group B. So modal age gives us the age, the approximate age of the student, the maximum number of students, they have approximate age 18.93 for the group A, which is greater than the maximum number of students having the approximate age 18.83 for the group B. Next is the following table shows the marks obtained by 100 students of class 10th in a school during a particular academic session. Find the mode of this distribution. So the marks given to us, they are in the form, it is less than 10, less than 20, less than 30. So basically these frequencies, these are not frequencies over here, these are basically the cumulative frequency, less than type frequencies, cumulative frequencies. So first of all, we convert this data into the class intervals. So the class intervals we will obtain corresponding to this, we are saying it is less than 10. It means the marks we are talking about, it is 0 to 10, it is 7. Then it is less than 20. So 10 to 20, how many students have these marks? It is 21 minus 7, that is equal to 14. Next, when we are talking about less than 30, so interval we are obtaining it is 20 to 30. So the value we obtain it is 34 minus 21, that is equal to 13. So we convert this data, the tabular form, we convert it to the class intervals. Now from this data, what we have to calculate? We have to calculate the mode of this data. So the maximum frequency we have it is 20, and it is corresponding to the class 40 to 50. So we are saying this is the modal class. So the value of xk we have it is 40, the value of h we have it is 50 minus 40 is equal to 10. The value of fi we have that is 20, value of fi minus 1 we have it is 12, value of fi plus 1 we have it is 11. So when we substitute these values in this formula, we get it is m, the mode of this data, that is equal to xk, that is 40, plus h it is 10, into the values we have it is 20 minus 12 over 2 times 20 minus 12 minus 11. So the answer we will obtain it is 40 plus 80 by 17. These calculations, these are shown over here. So on solving this, we will get the answer is 44.71, and this is the mode of this given data. Now next we have it is a comparative study of 3 measures of central tendency. So we are saying the mean is the most frequently used measure of central tendency, because when we are calculating the mean, we are taking into the account all the observations, and the value of the mean, it lies between the largest and the smallest observation of the entire data. So it enables us to compare the two distributions. So we are saying that if we have to compare the marks of student of different classes in a particular examination, we compute their mean marks to make the comparison. Now if we consider the case of median, so when there are some extreme values in the data, then we use median. What this extreme value means is, suppose I am talking about some wages or of the workers in the factory. Suppose the wages we are saying they are in this form, it is 100, this is wage for one worker. Then it is say 52, then it is 48, and then the next values we have it is say 20. Now if we have to calculate, or we are saying in place of 20, we are saying it is 47, then 47, the next value we are saying it is say 20. Now if we have to calculate the mean or average for this data, and if we calculate the mean, what we see is that most of the values they are lying in this region. Most of the values they are lying in this region, and this is the extreme value we are saying. This is much far away from this value. So to interpret this data using the mean, it may give us some unexpected results. So in place of mean, what we are going to do, we are going to arrange this data in the ascending order, and we are calculating the median over here. We are saying the mid value over here. These are the two values we are having. So we are saying the median we will have it is 48 plus 47 by 2, that is 47.5. So the median wage over here it is 47.5. So this gives us a better idea. Suppose I am calculating the mean for this data. So because of this value 100 over here, the mean might be deviated towards this side. So these kind of values, these are called the outliers, or these are called the extreme values. So generally when the data has the extreme values, we do not prefer mean, but we prefer, in that case, we prefer the median. So this thing is also mentioned over here. If the salary of one person is 10 times the mean salary of the others, then the mean salary of the group will be high. Suppose I am talking about, in place of this 100, if suppose the salary over here it is 1000, or the salary over here it is 10,000, then this one value will deviate the mean towards higher side. So in these cases, in these kinds of cases, we prefer the median as the better average. Next we are talking about the mode. So mode generally we use when we are talking about the categorical data. When we are talking about something, we are saying which is most popular item, or for example it is mentioned over here, if we have to find the most popular TV program watch, the consumer item is greatest demand. We are talking about the consumer item that is in greatest demand. So in all these cases we generally prefer mode. Suppose I am talking about this value over here, the consumer item in greatest demand. I am talking about, there are A, B, C, D, E. These are the items over there, and we are saying the demand of these items, say the demand of this item it is 2, the demand of this item, the number of persons purchasing this item it is 100, this is 8, this is 50, this is 17. So we are, if we calculate the mean of this data, we are not going to get any answer from this. So what we are saying, we will look at the maximum frequency over here. The maximum frequency is corresponding to B. So we are saying this B has the highest demand. So we are using the mode as the average over here. As the measure of central tendency we use over here, it is the mode. Similarly, we are saying suppose a factory is there, and that factory has to manufacture the shirts. So sizes of the shirts we are suppose saying it is say 36, 38, 40, 42. These are the sizes of the shirt, and this is the demand of these shirts. Suppose it is 34 over here, and these are the demands. These are 5, then there are 100, then this is say 200, then it is 50, and then it is 20. Now if we calculate the average of these values, that these are the size of the shirt and this is the frequency, that is the demand of the shirt. So if we calculate the average, we will not get any value over here. So we are saying that the mode over here, that is the maximum, the shirt that has maximum demand, it is of the size 38. So factory will be more interested in producing these shirts that have the maximum demand. This thing is mentioned over here, that a shirt manufacturer is more interested in the model size of the shirts sold. so as to produce it in the large numbers. So mode it is used in these kind of situations. Then we have an empirical formula. So this empirical formula we have it is 3 times median is equal to mode plus 2 times mean. This is not the exact formula we are saying. I am again mentioning over here. This is not exact formula, but this is just an general idea we are saying that if we calculate the mean, median and mode corresponding to some value, then then these 3 values they satisfy this formula approximately. This condition will be satisfied for median, mode and mean, that is 3 times median is equal to mode plus 2 times mean.